Hello everyone. Up till now, in our previous videos of this digital electronics series, we have learned about basic gates and we have learned about arithmetic gates. And today we are gonna learn about another important type of gates, that is universal gates. This is one of the most important type of gates. So coming into universal gates, there are generally two types of universal gates. Those are NAND and NOR. So why are they known as universal gates? So this is one of the most important question here. So why we are calling NAND and NOR as universal gates? So we are calling them NAND and NOR because as universal gate because in digital electronics, if you want to design any circuit, then you can design any circuit using these NAND and NOR gates only. So NAND, if you can use it universally to build any type of circuit. So that is why those are known as universal gates. So let us jump into first type of universal gate, that is NAND gate. As we have learned uh, for previous gates for output equation and truth table. So the output equation for NAND gate is A into B whole bar. So here you can observe a small not symbol here. So this indicates that the negation of this AND gate. So NAND is AND plus NOT. So this is the NAND gate. So here we are going NAND plus NOT. We are doing AND and we are keeping NOT operation, complement operation. We can also write this as A bar plus B bar. So let us find the truth table. Since we are having two inputs, then the possible combination of 2 power 2, that are 4 combination. We are having 4 possible combination here, 0 0 0 1 1 0 and 1 1 here, 0 2 3. So these are 4 possible combinations here. So let us write, if I am having 0 and 0, 0 into 0 bar, 0 into 0 0, and my output will be 1. If I am having 0 into 1, output will be 0 and bar, that will be 1, and 1 0 similar, 0 and 0 bar, that will be 1. If I am having 1 and 1, 1 into 1 is 1 and the complement of 1 is 0 0. So what we can draw from NAND gate is, if you are having any one of the input as 0, see, let us say here if any one of the input is 0 in an AND gate, then the output will always be high. If both the inputs or all the inputs of the NAND gate are high, then only the output will be 0. So this is the conclusion that we can draw from NAND gate. And next, coming to properties of NAND gate. So uh, I will explain why we are studying commutative and associative law after solving this one problem, after verifying this one. So let us take, what does commutative law state? If I am doing A plus B, then that must be equal to, if I am doing A plus B, then it is equal to B plus A. So this is what commutative law suggests. So let us verify if NAND gate is following commutative law or not. If I am having A and B output, then my output will be A into B bar. Similarly, if I am taking BA, then my output must be B into A bar. So this one, A into B bar and B into A bar are both are same. So we can write that NAND gate obeys commutative law. So what does associative law suggest? If I am having A plus B plus C, then that must be equal to A plus B plus C. So these two must be equal. So let us verify if NAND gate obeys associative law or not. Right. Here it will be, so these two are equal. A into B into C whole bar. So let us check if this one is equal to this one as well. A, B. If I am having A, B, then it will be A into B bar, and this one will be C. Why? Is equal to A into B bar into C whole bar. So this is not same. So associative, the NAND gate does not follow associative law. So this is the difference between all other gates and this NAND gate, because in all basic gates and arithmetic gates, all will follow both commutative law and associative law as well. But in when you are coming to universal gates, they will follow commutative law, but they will not follow associative law. So you may in gate and in PSUs or in ESUs, you may ask they may ask this question, whether they will give one condition. They will give universal gates one condition, and they will ask whether both will follow commutative and associative. Some will they will ask if universal gates only follow commutative law and they does not follow associative laws, and then you need to keep the option that says that the universal gate does not follow the associative law. So let us also learn about the enable and disable inputs of NAND gate. So coming to enable and disable inputs of NAND gate. So you are having A into B and C. So let us take C is equal to 0. Then my equation will be A into B into 0 whole bar. As we have learned that if any one of the input is 0, then my output will simply be 1. So let us check if C is equal to 1, A into B into 1 bar. So what we can suggest, then this will be A into B bar. So we can suggest, we know that if there is a change in output with respect to change in input, then that type of control input is known as enable input. For C is equal to 0, for even though if I change A and B values, I will always get answer 1. So this is the disable input. So there will be no change in output with respect to change in input. Whereas if I am taking C is equal to 1, then if I am with change in inputs, my output will also change. So this will be the enable input of NAND gate. So this is about NAND gates, and in further videos after solving NOR gate, we will also uh, we will also see how NAND gate will act as universal gate, and we will draw all the gates using this NAND gate and NOR gate as well. So stay tuned, subscribe the channel, and be safe. Thank you.